Afternoon, everyone. Right, okay. So, right after lunch, good time to learn GraphQL, I think. So, before we start getting into the formal presentation and throwing, words around like APL, queries, mutations, and stuff. What do we do today? I mean, in the applications you have built, for example, CodeFlakes or the team projects, etc., for data. Where do we store the data? What are the options for us today? Okay, I mean, in your project, in CodeFlakes, for example, where did you store the data? Backend, yeah. So by backend, what do you mean? A database, right? Eventually, right. So you can potentially have a file as a database, yeah, or a MongoDB, which is a NoSQL database. You can have a relational database like Postgres or something, yeah. Ultimately, it is about data. So you have a presentation layer, and you have the data, which is in different data stores. Yeah. Have you ever heard of APIs? Yeah. What are they? What is an API?
API is the connection between, let's say, a website and
Okay. Yeah. So let's break it down, right? Like David said, application programming interface, right? So it is the interface between your application and some backend data, basically. Yeah. Okay. So we have the GraphQL session. So what is a QL? You might have heard of SQL, SQL. What is SQL? Yeah, structured query language. So historically, it's we use SQL to query data from relational databases, yeah, like PostgreSQL or MySQL or Oracle or that kind of thing, right? So it is a declarative language, which is called a 4GL, fourth generation language, whereas in JavaScript, for example, you write imperative code, you drive code, and you say what you want, you define your functions, etc. With declarative code, you just say what you want, and then the system figures out how to get that data for you, right? So GraphQL, we're going to talk about a lot of these things. Like we're going to say APIs, we're going to say query languages, we're going to say graphs, etc. So before we go into that, I just wanted to make sure we're warmed up to those, words and stuff. Okay, right. Introduction. History, context, and adoption. GraphQL as a technology started at Facebook in 2012, and after using it extensively internally, they open sourced this as a specification. Yeah, this is not a library or a technology in itself. It is a specification more than anything else, which is open for adoption or implementation in the language of your choice, which was eventually owned by a GraphQL Foundation, which is cross-company open source foundation, and now it's been implemented using different languages, like JavaScript, Go language, or Python, you name it. Each of these languages have GraphQL implementations. Yeah. So what is GraphQL? It is a new API standard or specification, which is efficient, powerful, and flexible. We're not just loosely throwing these around. We will see why it is efficient, why it's powerful, why it's flexible. It is an elegant declarative data fetching language like SQL is, and it provides a single abstracted endpoint and provides us the backend stability for disparate data sources, and provides us a single entry point to access all the data that we need for our applications. So what is a graph in GraphQL? Whenever we build front-end applications, the applications have a data graph. So in this case, we have some books there, authors there, So books have a relationship with authors. Authors themselves can have a relationship with other authors as co-authors, for example. And then so books have titles, authors have names, and things like that. This is a data graph, yeah? And the whole idea of GraphQL is to query the data in the form of a graph. So how do we do that? This is a very simple example where we are querying a book based on its ISBN number and fetching the title and the list of authors. Yeah. And how does this fit into our graph model? If you look at the original data graph, we are fetching a subset of the data from that, through a query, which in itself is a query graph, basically. So we're starting from a book based on its ISBN number, getting all the authors and their names and the title of the book. So essentially, that's what it is, which is why it is called GraphQL. Yeah. So the features of this is it's efficient for data fetching, which we'll come to in a minute. Supports heterogeneous frameworks and platforms, and allows us to develop the features much more rapidly in comparison with historical API implementations like REST and SOAP, etc. Okay, so quick comparison with REST and GraphQL, basically. REST stands for Representational State Transfer. It is a way to build APIs which has served its purpose and simplified the way we expose data endpoints to different applications, etc. But it is quite rigid in the way things are implemented and where this specification is implemented in terms of the architecture. So this is an example of a REST implementation for, say, fetching the details of the users and their blog posts and followers, for example, right? So we have a client on the left and the data on the REST API endpoints onto the right. And if you need to show the users their posts and followers, we need to invoke the REST API endpoints here. So to get the username, for example, we invoke the user endpoint by providing the ID. And as you can see there, we are fetching all the data, not just the name, but also the address, birthday, etc. And the same goes with posts. If you just wanted to show the titles, you're also getting the content, comments, etc. Okay. So this is a typical REST implementation where you're getting the data that you're overfetching the data. And also in some instances, if you need additional information, you will have to use multiple REST endpoints to collate that information. So there is both the overfetching and underfetching issue in this case. With GraphQL, we have the ability to define the data we specifically need by going down the graph and querying exactly the amount of information we need. And this was particularly important for Facebook, for example, when they went mobile, to efficiently get the amount of data for, say, mobile devices with limited data plans, etc. And that is the beauty of GraphQL in this instance. So in a nutshell, the benefits are we no longer over or under fetch, just get the right amount of data. And we have a single access endpoint for GraphQL, which allows us to rapidly prototype the product or make changes to the product and iterate. Unlike the REST APIs, where if you wanted to make a change to get additional data, you had to rewrite or re-implement the API. With GraphQL, you have a single endpoint with the ability to query the data to your liking, basically. So which allows us to quickly change the application views with the data that you need. And the nice side effect of this is we have a clearer view of what the users are trying to fetch from the backend. With REST, all you're doing is invoking the APIs. So you are not you don't have the visibility of the user's intent there as to what is the kind of data he's looking for. With GraphQL, you get the analytics and have the insights into the data that they're trying to fetch. And you also have the benefits of a strict schema and type system that GraphQL provides through its specification. So we will go into a few core concepts of GraphQL and show demo the querying capabilities and how we make changes to the system. But I just want to answer any questions before we go into those details.
You're saying RESTful APIs are no longer really produced, everybody's now referring to?
Not quite. I mean, obviously, GraphQL has its challenges in terms of implementation here, and also there are REST has its benefits in terms of the way the APIs are defined and the data is cached through the CDNs and browser caches, etc., which fits very well in that paradigm. With GraphQL, obviously, you need to, re-implement those things. So there are places where REST is still valuable, and for heavy data-based applications where you know for sure what you're getting, then REST is still still has its advantage, basically. Yeah. So in case of UI-based applications where you want to rapidly change the application or the view models, etc., GraphQL gives us the flexibility and also just the right amount of information where we need. Yep. Any other questions? Okay. So, few of the core concepts or constructs of GraphQL. So we have a schema definition language for GraphQL, where we define our data schema, and also we have some root schema types like the queries, mutations, and subscriptions, which we'll come to in a bit. So historically, you would have heard of CRUD operations with databases. So create, read, update, and delete. And it is the same here. So essentially, when you need some data, you query the data. And if you need to create some new data, then you use the create operations. Then you use the update or delete operations, which is no different. Yep. Look, have a quick look at how the data is queried, for example, right? So all persons here Is that? Yeah. Yeah. That is a query operation, as you can see. Yeah. Which gets the details from the person object. Yeah. And we're fetching the name, age, and the posts in a child object, basically. Okay. And the result is a JSON. Yeah. Always. And so we're getting the data back for the all persons query. We have different users and that, blog titles, etc. Yeah, as simple as that. Okay, and we can also pass parameters, just like the where clause in SQL, for example. Right? I just want to get the last two users in this case, or persons in this case. Right? Yeah. It just happens to be that someone has inserted the same user twice at the end. If you look at the previous data here, so we've got Alice twice here, and that's what we're getting back. And you can obviously filter based on name or age and things like that. Yeah. And so that was basic querying with arguments. Yeah. And any create, update, and delete operations are called mutations in GraphQL. And a simple create operation is defined as a mutation, which is a root operation type, basically. Yeah. So here we're creating a new user, a new person called Bob, and GraphQL gives us the ability to return data as part of the mutation, basically. So while we create the person here, we're also returning the ID of that person. We can get any data we like from that object, basically. Yeah. And so once we've created this, if you go back and query again, so you have a new user Bob there. Yeah. So this is no different to traditional database querying or create, read, create, update, and deletes. Yeah. There is also the concept of subscriptions, where you can subscribe to events on the GraphQL server, and whenever the data gets updated on the server, the subscriber gets notified of the change. Yeah. So yeah, and there are different implementations of this. Again, GraphQL is not prescriptive as to which protocol you use. So people, you can implement GraphQL using standard TCP or HTTP or WebSockets. It's your choice, really. Yeah. So in summary, in our schema, for example, we have a few root types like query, mutations, subscriptions, and we have our own custom definitions like the person and post. Person and also we can define the relationships between the objects. So the blog post object there is related to the person, as you can see there. Yeah. And the person has a one-to-many relationship to the post. So as you can see, post is an array of posts, essentially. Yeah. So there are obviously, if you look into the documentation, you can see the specifications of how to define the schema. Okay. So the high-level architecture here. So we have a client, we have a GraphQL server in between, which can be directly hooked to a database and to get the data, And GraphQL can also serve disparate data sources like some legacy systems or microservices or third-party APIs. So which is very flexible in terms of what you can do with it. Okay, and the way that this GraphQL allows us to do this is through a concept of resolvers. They're essentially functions, if you will. So each object that we are querying is has a specific resolver that can go and query the data source where the data is coming from and aggregate the data and pass back to the user, essentially. Okay. So is everything, is it the next big thing, or are there no downsides to GraphQL? There are a few things that you need to consider when you go for GraphQL implementation. So it doesn't currently provide inbuilt schema versioning, so you need to do that using your own version controlling systems. And also, obviously, once people have or the application has got access to the GraphQL endpoint, people, if you're not careful enough, you can impact the data sources quite heavily, because people tend to loosely use and write very complex queries. So we need to be mindful of that, and also understand what are the typical optimizations that are required to query different kinds of data sources. Document data source, query can be optimized. It needs to be optimized in a certain way, as compared to an Oracle or relational database, where you need to understand how the database or tables are indexed and that kind of thing. So obviously you need to make sure you're querying appropriately. Yeah. And also authorization is a big thing. So people tend to put the authorization, code the authorization between GraphQL and the backend data sources fine, but leave the querying open to the front end applications typically. So they need to make sure they use the right query context and limit which application or module can access what kind of data. So yeah, a few things to bear in mind, and I think that's it. Sure. Yeah.
I think you see the benefit of using GraphQL between the front end and the back end, because it simplifies it. It does provide the process of creating APIs, so
Yeah.
that's all good. But my question is on the other side. So how GraphQL in the back end, how's the persistency working, right? Because if I have my own database in MongoDB, for instance, right? So how is GraphQL dealing with all these requests?
The GraphQL server is responsible.
GraphQL server.
Correct. So in the architecture here, that little thing in the middle is the GraphQL server. Yeah, which is responsible for interacting with all the backend data sources.
So is the GraphQL server handling persistency? It's like a database at the end of the day.
The GraphQL server itself is not a database. It can be backed by a database or a NoSQL, backend, or another third-party API. It's just an aggregator, basically. Yeah.
How does it interact with the actual database?
It uses the right drivers to talk to the, say,
So is it
for
acting as a middle tier?
exactly.
It's
Yeah.
a middle tier.
It is a middle tier. Yeah. Yeah.
It's making the query.
Yeah.
The subscription
Model, I mean, that's significant, potentially very useful.
It is. Yeah. Yeah.
functionality.
Yeah.
But as I guess somebody, as Ricardo was alluding to, secret sources all in the middle tier, right? That's a lot.
That's right. Yeah. Yeah. I mean, there are different implementations of GraphQL, GraphQL server and clients. Apollo is one of the most famous one, and Facebook has its own called Relay, which is not very cross-platform friendly. So I think, so Apollo is the quite widely used one. Yeah.
Based on your experience, do you think that GraphQL is suitable for small projects, or is it like too much?
If you've got a single data source, I don't really see a lot of value with using GraphQL. Obviously, if you want to build APIs, then definitely there's value with GraphQL. Then your clients don't have to change, or you don't have to re-implement APIs whenever there's a change in requirements. So GraphQL definitely is good in that context. So if you have multiple data sources in the backend, or if you've got changing API requirements, those are the drivers to use GraphQL, I think. Yeah.
The overfetching and underfetching that you mentioned.
Yeah.
Although from the client it's gone, presumably it's still really happening with the data.
Not really, because your resolvers, obviously it's down to your implementation. Yeah. If you still use the bad practices from the old school, and just fetching a lot of data and just filtering that data and providing the client, then yes, it is. But if you're resolving the client requests to the appropriate granular sort of backend requests, then you are just getting what you need to. Yeah. So there are some very good resources that I will share after this presentation, where you can go and play with GraphQL and also implement it in the context of React, basically. Yeah. So that's that.
What is the perfect use case or the perfect scenario for GraphQL over SQL and NoSQL? What would be the...
If you have multiple data sources, you can aggregate them and create a single application sort of schema graph, basically. Yeah. And so essentially abstract your NoSQL, RDBMS and third-party APIs all into one. Yeah. So you have a single application sort of schema that you can query from. Yeah. And again, so your question about REST versus GraphQL. As you can see, we're bringing, there is a concept called shared nothing architecture, right? Where you're splitting responsibilities and reducing single point of failures, etc. Obviously, GraphQL server becomes our single entry point to our schema in this case. Yeah, with REST, you can implement each API and get the data from separate data sources. So if that is your requirement, then with GraphQL, again, you'll have to have separate servers and that kind of thing. So there are trade-offs, again, and that's the benefit as well in this case, having that single entry point to get all the data. But again, which is the downside as well. Yeah. Thank you.